right, we are recording. I'm going to share my whiteboard. So we'll start with number 11, and that's where we have the graph that crosses at -4, and this is the graph of f prime. So on that, if f prime is negative, then the graph is decreasing.
Okay.
Where f prime is positive, the graph is increasing. So the graph of f, oh, I lost my chat box, darn it, is going to decrease and then increase at -4.
Okay.
And I may have lost Libby and Jordan because their little boxes aren't popping up on the side of the screen. Are they popping up on yours?
I can see Jordan's, but I can't see Libby.
Well, look, I've got a
I
chat.
think Libby's gone.
Yeah, she froze up.
Okay.
Jordan, does that make sense on number 11? Were there any other questions, Susie?
Number 15, I don't think I did it like right at all.
Okay.
You had a lot of words on it.
Okay. Yeah, a lot of people had trouble with that one. Okay, so on 15, we have g of x is equal to 2x cubed plus 6x squared minus 7. And so we want to know where it's increasing and decreasing. That's our first derivative.
Okay.
So we do 6x squared plus 12x. And then you set that equal to 0.
Okay.
So I'm going to factor an x out. So x equals 0 and 6x plus 12 equals 0. Bring the 12 over. I know I paused, but okay. I was remembering something wrong and it was messing with me. So there's two places where the derivative is 0. That's at 0 and -2. So those are maximums and minimums. And we've got to decide which one it is. So if we look at the graph of an x cubed, it'll go like that. And then -2 will be our maximum and 0 will be our minimum. So we're going to increase from -infinity all the way up to -2. And then from -2 to 0, it's going to decrease. And then it starts increasing again from 0 to infinity. Whoops, not -infinity. I have a really cool pen, though, that'll erase just with a click of a button. It's supposed to. And then it doesn't. Okay. Let me go back to my pen. So 0 to infinity. Okay. And so that's the first derivative. Let me wait a second. Jordan, did you understand that? Okay. So I'm going to clear this and then I'll go to the second derivative. And the second derivative will tell us concave up or down. But before I clear, if you look at the graph of the x cubed, we have an inflection point where I just put that dot. So it's going to be concave down until that inflection point and then concave up after it. We just need to find out where that inflection point is.
Okay.
Let me clear my screen. And then we'll take our first derivative, which was 6x squared plus 12x, and we'll take the derivative of that. We get 12x plus 12. Find out when that is 0. We'll divide by 12.
Yeah, I just saw that it was negative, so I was just like, oh, concave.
Right. So if you did the second derivative and it came out just to a constant and that constant was negative, then it would be concave down the whole time. If it was positive when you did the second derivative, concave up the whole time.
Okay.
But this tells us where the inflection point is. So from negative infinity to -1, we're concave down. And that was based off that drawing we had before.
Mm-hmm.
And then from -1 to infinity, we're concave up. Now, if you were dealing with a graph that you didn't know the shape, then you could take a number less than -1, plug it in to the second derivative. If it came out negative, you'd be concave down. Came out positive, you'd be concave up.
Okay.
Okay, any questions on that one, Jordan? All right. Susie, any other questions?
Yeah, ma'am.
All right, so Jordan, tell me which one you want to work on first. Integrations with the graph. Give me a second. Let me see if I can find my worksheet on that. Oh, okay. I know what you're talking about. Let's see here. I'm gonna have to swap out of Zoom for a second to pull that up. So there's no telling what you're gonna see. You may still see my screen and see everything I do, or it may go back to my face. I don't know. Let me make sure I didn't bring home a copy of it because that would be way easier. I didn't, but I took a picture of it on my phone, I think. Because I'd rather not switch screens because that would be weird.
Libby said that her internet stopped working.
Oh no! Hold on. Hey Becca, help me out. Plug me in. My battery's about to die. But Becca's helping me. She's gonna plug me in so that we don't lose it. I found the integration worksheet. Okay, so Jordan, on that first graph with the picture, it says y equals x plus 1, and then we're shaded all in here. And then we have 1 and 2. Okay? So we're looking at the integration from 0 all the way to 2 of x plus 1. Do you work these out on your calculator with that little integration button? Okay, so that's how you would set those up. You would just look at which part is shaded, and it went from 0 to 2, and then type that into your calculator. Do you need more on those, or does that answer your question? Okay. Were there any other questions on the integration worksheet? All right. Any questions on the calculus review? Number 1. All right.
Oh, Libby's back, I think.
Olivia, are you there?
It shows her box.
I don't know why I can only see your box, Susie.
You can't even see like their name on a gray box.
Mm-mm.
I can. It just says it's just a gray box and it says Jordan, and then a gray box that says Libby.
That's funny. I don't have either of those, but I have your face, so that helps me feel like I'm teaching to somebody.
Do you have Libby's face now?
Nope.
Really? I can see her face now.
I'm wondering if I clicked on your picture or something, and that's why. I'm not sure, but we'll work number 1. And then Libby, if you come up with questions, just type them in the little chat box. So number 1 says a particle moves along a circular path determined by x squared plus y squared equals 9. Find the rate at which the x coordinate is changing the instant that it passes through the point 2 square root of 5, assuming that the y coordinate is decreasing, so that's dy dx, negative 2 units per second. Okay, so all that was given. So the first thing we want to do is the derivative. So to do the derivative, you have to use, what's the word I'm looking for? Implicit differentiation. That's where you include the dy and the dx. So we'll do 2x dx plus 2y dy is equal to 0. And then we're solving for, find the rate at which the x coordinate. So we want to know dx dy, or excuse me, dx dt. At that point, okay? So we'll divide everything by dt, and that should be a dt as well, sorry. Divide by dt. And then, which one are we solving for? Dx dt. So I'm going to bring the 2y over. And divide by 2x. Negative y over x dy dt. And then you just plug in. So you'll do negative y, that's negative square root of 5 over x, which is 2, times negative 2. And that'll give you the positive square root of 5 units per second. Any questions on that one?
No, ma'am. That makes sense.
All right, what questions did you have next? There's Libby. The you disappeared.
Yes. Okay, I connected on my phone.
Okay.
Hey, we can hear you now.
Yay. Okay, good.
All right, what question do you have?
Okay. On the through lesson 56, number 15.
Yeah.
How do you do that?
I want to see your whole problem, Jordan. Let's see. So you start by doing the derivative.
Yes.
And I can't remember what you got wrong on that.
Yeah, I'm gonna try to find it on my computer. Our Wi-Fi is not working very well.
I know, of all times for it to go haywire. All right, so we're going to solve. So I'm going to factor x out. X is 0. 6x plus 12 is 0.
Oh, Libby, I see you twice.
Oh.
You see me twice?
Yeah,
your computer.
Your computer was frozen, so.
Oh, because it's locked. Because my computer isn't on it anymore.
Really?
Yeah.
All right. So after you do the derivative, you get 0 and negative 2. And so an x cubed graph does that.
Mm-hmm.
So we have a maximum at negative 2 and a minimum at 0. So we're looking for increasing and decreasing. So we're increasing, decreasing, increasing.
Oh, okay. I got the x is negative 2 and 0. I just didn't get the rest of it.
Okay. So I think you had part of the increasing. A lot of people did. They just left out the negative infinity to negative 2.
Okay.
And the 0 to infinity. And then decreasing would be from negative 2 to 0. Okay, and then the second part was concave up or concave down. So you take that first derivative and you're going to do the derivative of it, which gives you Ooh, I don't know what that was. Anyway. Which gives you 6x plus 12. And then when is that equal to 0? So you bring the 12 over and divide. It's not 6x plus 12, it's 12x.
Okay.
There we go. And so x is -1. So that's where the inflection point is. That's that point right there. And so we're concave up, if you look at the graph, from negative infinity to -1. And then,
Oh, that's where you're concave up.
oh no, backwards, sorry.
Okay.
Concave down because it's like an umbrella. From negative infinity to -1, and then up from -1 to infinity.
Okay.
Okay.
All right.
Also find that by plugging in numbers to the left and right of -1. If they come out positive, it's up. If they come out negative, it's down.
Got you. All right. That makes sense.
Clear this. Okay. What else do we have trouble with?
That's all I can remember.
What about you, Jordan?
That's all I can remember.
Okay. Yeah, I don't think you missed much on the review.
Okay.
And your picture was real tiny, so when I tried to write on it,
Oh, I'll
It
try to
made
make it bigger.
really big. So
Gotcha.
it was kind of hard to read.
I
could
wonder how to
zoom
make
in.
it bigger.
Huh?
I'll ask my mom how to make it bigger.
Yeah, I was able to zoom in and read what you put. And when I went to mark on it, it wouldn't let me mark on it zoomed in. That's why
Okay.
it looks really fat where I wrote.
It's not letting me open it right now, the corrections, but maybe it will later.
All right, Jordan, do you have any other questions? Okay. Well, after spring break, I'm going to start doing the Zoom every day
Okay.
class. I will probably try to keep calculus at 11. And then I'll keep recording as well and posting those. So if it recorded correctly, we'll see.
All right.
Well, if I don't have any other problems, I'm going to log off and try to post this. We'll see how that goes.
All right. Thank you, Ms. Reed.
Thank
You're
you.
welcome. Hope to see y'all
Bye.
next couple weeks or so.
Bye.
Bye.